Hi, I'm Kelly from WILDCOAST. Today's lab is called Alginate Gummies. It will demonstrate why marine protected area conservation is so important through a fun and exciting lab, where we turn kelp and/or seaweed into a tasty treat. This lab is geared toward middle school students, but the chemistry lesson can be adjusted for all ages. Did you know that a lot of the foods you eat are made from a type of polysaccharide called alginate that occurs naturally in all brown algae, sometimes known as kelp or seaweed? It's true. You might perceive eating seaweed as gross, but the same polysaccharide that is found as a skeletal component of kelp's cell walls is also used to make ice cream, fruit-filled snacks, salad dressings, some onion rings, and many more everyday foods. Alginate is used in food because it is a powerful thickening, stabilizing, and gel-forming agent known as an emulsifier. Most alginate that's used in foods is in the form of sodium alginate, which is also the kind we'll be using today. Now let's talk about the science behind this. In order for sodium alginate to become a gel-forming agent, it must come into contact with a more attractive ion, such as calcium. As soon as sodium alginate is added to a solution of calcium chloride in water, a gel forms as the sodium ions are exchanged with the calcium ions, and polymers become cross-linked. This cross-linking of the alginate polymers via calcium ions forms longer polymer chains, thus creating the structure of the gummy worms we will make today. Here's an example of the chemistry with paper clips. One paperclip represents a monomer. A monomer is a molecule that can react with other molecules to form polymers. So me connecting these paper clips together is an example of a monomer undergoing polymerization to create a polymer. In our lab, we are working with two polymers, sodium alginate and calcium chloride. During the chemical reaction, the two polymers will link together in a process called cross-linking. The supplies used in today's lab can be ordered online or found at specialty food markets. We suggest telling the students that a good rule of lab safety is to never lick the science. But just in case one of the gummy worms ends up in someone's mouth, make sure to purchase all food-grade materials. Don't tell the students that they're going to be making gummy worms, but have them make a hypothesis about what will happen when all of the ingredients are mixed together. For this lab, you will need sodium alginate, calcium chloride, warm water, food coloring, or flavored drink mix if you'd like for the students to be able to eat the gummies, a mixing bowl, a measuring cup, measuring spoons, and a clean syringe or squirt bottle. There are a few things that you will need to prep before the class. I'll go ahead and demonstrate those now. We'll begin with the sodium alginate. We recommend prepping the sodium alginate ahead of time because if you put even the tiniest bit of extra sodium alginate in the mixture, it will get too thick and clog the bottle and the experiment won't work. You'll start with half a cup of warm water. Add 1/4 teaspoon of sodium alginate. Stir in sodium alginate slowly because it does clump up. Alternatively, you can use a blender and blend it into the water. Don't make the solution too thick, otherwise it'll clog the cap on your bottle. As soon as the sodium alginate mixes with the water, it will start to absorb the water, making it turn into a gel consistency. At this point, you can mix in a flavored drink mix if you'd like. Add about a teaspoon of the drink mix if you decide to. Since we tell students to not lick the science, I will add food coloring rather than drink mix to give it a cool color. A drop or two is fine. We recommend using 1 or 2 different colors for each group. Now set this aside. This next step the students will do themselves. They're going to make the calcium chloride solution. Have them take 2 1/4 cups of water and mix with 3/4 tablespoon of calcium chloride. Stir until the calcium chloride has dissolved. This solution is safe for students to touch so they can stir the water and calcium chloride with their fingers. Now comes the fun part. Fill a clean syringe or squirt bottle with the sodium alginate solution. Make sure to have enough syringes or squirt bottles so each group gets 1 to 2 colors. Only fill the bottles a little bit because each group will be using all the sodium alginate, and we want to make sure we have enough for everyone. Carefully squeeze a stream of the sodium alginate mixture into the calcium chloride solution. As soon as they touch, they will undergo a chemical reaction like we had discussed before and create edible gummy worms. Leave the gummy worms in the water for at least 10 seconds. Students can then fish them out with their fingers. If students are going to eat the gummies, make sure to rinse them off as the calcium chloride is salty. After the experiment, ask the students what the gummies they made and all of the other foods like ice cream, fruit-filled snacks, and salad dressings have in common. They should understand that all of these foods have alginate, an ingredient made from kelp, in all of them. Ask students what would happen if all of the kelp disappeared. In relation, ask how MPAs, or marine protected areas, help protect our gummy worms. WILDCOAST is working in the 11 MPAs in San Diego County to protect and conserve the marine life in their habitat, including kelp forests. So in a way, WILDCOAST is working to protect our delicious gummy worms. I hope you enjoyed the lesson. If you are interested in more resources you can use in the classroom, log on to wildcoast.org and click on the Resources tab at the top of the page.